Hi everyone, thank you so much for coming to this video. So today we're going to be going over differentiation for gradients and differentiation from first principles. So reviewing the videos on on differentiation and straight lines will be really useful for this video. So the learning objective for today is to be able to understand and use the derivative of f of x as the gradient of the tangent to the graph, to be able to understand and sketch the gradient function for a given curve, and to be able to show differentiation from first principles, specifically for sine and cos. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So if we move on to the first learning objective, to be able to understand and use the derivative of f of x as the gradient of the tangent to the graph. So let's say you have a function f of x that's equal to x squared, and we want to find the derivative of that. You could just, the notation you use is f dash of x, that would just be equal to 2x. So if you don't remember how to do differentiation, make sure you review that lesson. And we can also write this function as y is equal to x squared. And then we can say the derivative is just dy over dx, and that's just equal to 2x. So we have these two notations to write out what the derivative of the function would be. So we have either f dash x or dy over dx, and they just mean the same thing. It just depends on whether they give you your function as in the form f of x or just y equals something. So let's say we wanted to find the gradient of this curve, y equals x squared, at specific points, x equals 1 or x equals 2. So to do that, you just if we have x equals 1 like this, we just want to we just want to draw on the tangent of the graph at that specific point, like this, and then you just want to find the gradient of that tangent, because remember that a tangent just touches the point, just touches the graph at one point, but then the gradient of the tangent is just equal, it's just parallel to that curve at that point. So then all we have to do is we can just work out the equation of the tangent, and that would get your gradient of the graph at that specific point. So if we have the gradient of tangent at x equals 1, using this, if you remember that the gradient is just the change in y over change in x, so we just have dy over, let me do this another colour. So for x equals 1, we just have dy over dx, and that's equals to the change in y, which is just 4, over the change in x here, which is just 2. So that's just equal to 2. So I've just drawn on the tangent here and then plugged in the differences for you. So we have 4 over 2, just to show you how that works. But equally, to get the same answer, if you do like f of dash or dy over dx, if you just differentiate your function x squared, so we had 2x, and then if you just plug in x equals 1 to that, so let's say we did f dash of 1, you'll just get 2 times 1, which is just equal to 2. So to find your gradient at a specific point of your graph, you just work out the gradient of the tangent, but that's the same as just writing, if you do f dash, if you differentiate your function and then you just plug in your value that you want to find into your derivative function, and then you should just get your answer, which is the same as if you were just to work out the gradient of your straight line, which is your tangent, just using the change in y over the change in x. So now if you were to try the same thing for x equals minus 2, so we can just write out what dy over dx is using the tangent at that point, and we know that the change in y, that's just 8, and our change in x, that's just minus 3 minus 1, so that would just be equal to minus 2. So that would just be equal to minus 4. And you can do the same thing if you plugged in f of dash of minus 2. You just get 2 times minus 2, and that's just equal to minus 4. So that's your gradient of the graph at the point x equals minus 2. So if you have a function and they've asked you to find the gradient of the graph at a specific point, all you do is you just work out the gradient of the tangent at that point, which is the same as if you differentiate your function and then you just plug in your value that they're asking you to find, then you will get the gradient of the graph at that point. So now let's move on to sketching the gradient function for a given curve. So in order to sketch the gradient function for a given curve, let's say you had the curve y equals x squared and you've asked to sketch the gradient function. All you do is you just work out what the derivative is, so dy over dx, and that should just be equals to 2x. So now you can just draw the curve like normal. So you just have here is just x, and your y-axis would just be dy over dx. So you can just draw in a normal graph of 2x. So that would just be something like this, and you have that as your dy over dx is equal to 2x. So it's not that complicated to draw the gradient function. All you do is you just differentiate your normal curve to find dy over dx, and then you just draw that like normal with your x-axis being x, for your y-axis being dy over dx. And that's all you have to do. So let's try an example. Let's say you had y equals x cubed, and you're asked to draw the gradient function of that. All you do is, so pause the video and try it out for yourself first. So all you do is you just do dy over dx, and you get that is equal to 3x squared. So now we just want to draw that like normal. So you would have x here, and you'd have dy over dx here. Then if you were to draw 3x squared, it would just be a graph like this. So that's your dy over dx is equal to 3x squared. So that's just a quick overview of how to sketch the gradient function for a given curve. So now that we've worked out how to use the derivative of fx to find the tangent or the gradient of the curve, and we've been able to sketch the gradient function for a given curve, let's try an exam question. So we have an exam question here. Feel free to pause the video and try it out for yourself first. So we want to find the gradient of the curve y equals 1 over root x plus 1 over x at 4 and 3 over 4. So the first thing you want to do is we want to rewrite this equation using indices to make it easier for us to differentiate. So we could say that y is also equal to 1 over, if we rewrite this, it's just x to the power of a half plus, if you remember, 1 over x, that's just the same as x to the power of minus 1, so plus x to the power of minus 1. Then we can also rewrite this. Remember, if it's 1 over x to the power of a half, that's just the same as x to the power of minus a half plus x to the power of minus 1. So that's what y is equal to. And now we just want to do dy over dx. So if we do dy over dx, we just differentiate each term individually. So we would get minus a half x to the power of minus 3 over 2 minus x, and if we subtract 1 from this power, minus x to the power of minus 2. And now, because we want to find the gradient of the curve at this point, all we do is we just plug in our x value, which is 4, into our dy over dx. So at x equals 4, so then to find the gradient at x equals 4, we just say that dy of dx is equal to minus a half times 4 of minus 3 over 2 minus 4 to the power of minus 2. And then if you plug this into your calculator, you should get that dy of dx is just minus 1 over 8. And that's your answer to this question. So the key here was just to rewrite your equation of the curve in an easy form to differentiate using indices like we did here, and then you just differentiate it normally and then plug in your x value of your coordinates to get the gradient of the curve at that specific point. So now that we've covered all these 2 learning objectives, let's move on to the last one.